This will be our last session today. It's not so late. Yeah. So the idea of this session is that you can complain or make questions or even make some compliment, to people that are in the committee. So here, I think you probably know all of them. But anyway, we will make a round so everybody introduces him, herself, and tell us when they joined the committee, which national body they are representing, what they more or less do in the committee, and so on. And after that, if you don't have any question, I will try to invent something. So let's start with Danny, and then I will be the last one.
So, my name is Daniela Engert. I'm a member of the German national body. I was a guest in 2019 for the first time at the Cologne meeting, and then for 2.5 years a submarine member of the committee, and afterwards I became an official member.
So I'm Michael Hava. I'm a member and co-founder of the Austrian national body. My first meeting was also the Cologne meeting, and what I saw there was so funny that I decided to join the committee as soon as possible. And the first meeting I attended officially as a member was the Prague meeting, where we finalized C++20.
Okay, hello, I'm Dietmar Kuhl. I'm working at the committee since 1996. Stockholm was my very first meeting. Over there I was told that it's a great learning opportunity to go there, and I had no clue what they were talking about, so I went. Since then I was mostly working in the library area. I pushed for the, or worked on the IO stream and locale stuff. And then nowadays I'm co-sharing the library working group.
My name is Mateusz Pusz. I am the co-founder of the Polish National Body. I'm in the committee from, I think, September 2015, although I have skipped the next meeting right away after my connection to the committee because it was Hawaii meeting. I didn't want to be perceived as the guy that goes for vacation. So actually, my first meeting that I attended was in Toronto, which was the first meeting for C++20. So I was there for 20, 23, 26 rounds, not missing any meetings at all. And yeah, I'm mostly active in LEWG, so this is Library Evolution Working Group, and I'm also the author of MP units that was mentioned a few times in the previous lecture, which hopefully will be a part of the standard in the future as well.
And I am José Daniel Garcia. I am a co-founder of the Spanish national body. You can measure my time in the committee for the first meeting I joined. That was 2008. But a different metric is how many times I've been in Hawaii. I think if I am right, at least I've been there 6 times. So a long time. My first meeting was 2008 in San Francisco. I was also the organizer of the meeting in 2011 that happened in Madrid. So this is where we approved C++11. And well, I am in different groups. So I'll tell you something. When I joined the committee, my initial plan was to join the concurrency and parallelism group, because that was my background in research. I think I've been no more than 1 day in any meeting in that group, because always something more interesting was happening in a different room and I had to go there. So most of the time I am in the evolution working group, which is the group trying to keep consistency between the language, a little bit of the library, and also to define the direction that the language is taking. And I also regularly have been participating in the contact group, and lately in the safety and security group. So as you see, I am a bit eclectic in the things I am interested in. So I think that's it. And let's do, by the way, you told me that I was good volunteering people. So I will volunteer Santiago to take the microphone to whoever who wants to make, questions, complaints, or whatever.
Complaints preferred.
My thing is rather just a recent idea I had in mind regarding C++. So at my job, we quite often suffer around like figuring out some non-deterministic behavior, like flaky test or like some bugs which are not reproducible due to like somewhere we took like datetime. And I was thinking whether would it be a good idea to like provide some such feature to language to annotate functions with like deterministic keyword or something like this, so that we could like mark the code as deterministic, and so that compiler would not allow us to call like anything like random or datetime in such functions. So to make sure that we have like this code deterministic, and we could just have such compile time guarantees.
He claims it's library. I go, no. No, definitely not library. Annotations would certainly go into the language. Whether such an annotation would be particularly reasonable, I don't know. Because in principle, I would claim, well, all our code is supposed to be deterministic. In fact, even random generator code happens to be deterministic. I know that doesn't make any sense if you look at a face value, but it's really just a fixed computation unless it calls out to I/O or something like that. So maybe the annotation would be, does it call out of process in some shape or form? I listen to I/O. But
yeah, well, the first source of non-determinism is you have undefined behavior.
That's true.
And by definition, we try to reduce undefined behavior, but some undefined behavior cannot be diagnosed. So we cannot eliminate all undefined behavior. And the other thing is that if we do that, we are putting a lot of barriers to optimization. So you want your code fast, so it's sort of contradictory, isn't it?
So basically, compiler cannot tell whether a function is UB-free or not. It doesn't know.
It can find some kinds of undefined behavior, but not all of them.
Okay, so it will be impossible to implement it. Okay.
Broadly speaking, we don't want undefined behavior. Mm-hmm. We say something is undefined behavior because we have no way to at least efficiently determine whether that the precondition or whatever is required is met. Otherwise, we would do it. Like an example is the compiler wouldn't know if a reference to an object is actually valid when you call the function.
Mm-hmm. But I mean, for example, let's say we have a very simple function that like computes a square root, or like it doesn't do like any weird stuff. Can't we just prove that this function is UB free? Still no.
No.
So UB would be still in that function and not in the caller.
Yes, it will.
Well, the undefined behaviorness is not in the function. It's not in the square root function. Mm-hmm. The square root function would be fine. The caller is calling things possibly out of contract, which we cannot or don't want to check.
Yes, but can't we check this square root function and just let it be marked as...
You are asking for a different square root function that has a context precondition. This we do not have today. Now, there are a couple of things. Once we have context, we might start to have more library functions with context annotation. That is one thing. Now, another thing that Daniela mentioned this morning is safety profiles. So with safety profiles, we will start to have some of those annotations so that we can have code where, if possible, we can diagnose some undefined behavior. Anyway, you would be sometimes surprised how code that you think is completely deterministic, it's not. For example, assume you have a Boolean function that returns that I plus 1 is greater than I. And you would tell me, of course, this always returns 2. And I will tell you, no, not necessarily.
When it wraps around, you mean?
Well, no, it's worse than that, because if I is an integer, then it's undefined behavior.
Okay.
So that's tricky. But these tricky things are part of why we have a great performance. So we need to balance.
Yeah, breaking preconditions is undefined behavior, right? Some of them can be checked, some of them not. Like, for example, every C++17 algorithm has a hidden UB. Just pass 2 iterators from 2 different containers to one range to one algorithm, right? It can't work. And you have no ways to actually prove they are from the same container in the interface of the algorithm, right?
First, I would like to add on the first part of the previous question. The source of indeterminism, in your case, if I understand correctly, was stemming from a clock, right?
Yes.
So there is a notion of, let's say, at least semantical notion of pure functions, which the result depends solely on the past parameters, and this like a more strict subset of deterministic functions. And if probably there was some proposal about having pure functions directly annotated in the language. Is this correct?
In the past, there was some proposal, it didn't fly. Sorry. In the past, there was some proposal at some point to have a pure attribute a few years ago, but it didn't fly.
What was the problem?
I cannot remember at this point.
Okay, we
sorry.
may dig a little bit into the history.
Just one more thing. The approximation to that is not exactly the same, but an approximation is a concept per function.
And you need to be aware that every annotation that you put onto a function is also a promise, and you can break promises. And this is one of the reasons why some, in theory, good proposals don't fly in the committee, because we need to make sure that whatever we do is actually correct as much as we possibly can.
And another question from me is that currently there is a certain point of view in the C++ community about the way that committee manages its decisions about backward compatibilities in multiple instances of multiple areas of the language. And to highlight one is ABI.
The standard doesn't speak about ABI.
I know we shall not. Are we recording, by the way?
The committee does, though.
Yes.
And so the argument goes. The argument of someone who actually wants the language to progress faster and to break some eggs is that yes, we to a certain degree we might abandon backwards compatibility for particular, or maybe make it opt-in or opt-out, whatever. And yes, there will be users that won't be able to upgrade to the new versions of the compiler because of that, because there are a lot of binaries which is impossible to rebuild from sources. They're just a huge legacy pile. But those guys probably do not upgrade their compilers too often. And probably we should not think that much about them. And probably we should think more about the part of the C++ programming community actually wants to utilize all the new functions, all the newest compilers, and all the benefits that breaking ABI might bring us. What do you think about it?
As you may have noticed on my slide, the last sentence was, I think we should break ABI.
I missed that. Amazing.
Yeah, this is also my opinion, right? But the problem is that in the committee, we cannot agree. We voted several times already, and it's always 50-50.
Just one? You need just one person? Right, I can go.
Not one person.
Just tell me where to go.
We voted many times there, and it's always 50-50, so we cannot agree what's the current direction. That's actually, we lost plenty of people from the committee, like Google, for example, and other companies as well, right? I personally feel that we should break the ABI often, so people stop depending on it. Having great package managers like Conan or VC package allows us to rebuild everything from source easily with every new release, right? And actually, it should be project hygiene to actually rebuild some stuff with a new toolchain every time to have proper security fixes in the compilers, right? Like Meltdown, Spectre, right? And all of those things. If you have library compiled and linked 20 years ago, you are still prone to those, right? And expecting everyone that they will not break ABIs because you have a library from 30 years ago that you want to link with your project and you still want to use coroutines or I don't know, the reflection in your project, it's not problem of entire community, right? And just to add one more thing. Today I learned that Clang 19 will never actually compile my MPUnits project because they had a bug in the first version of Clang that they released. The fix actually breaks ABI in Clang, so they are not merging this fix to Clang 19 because it's a breaking change for ABI of Clang, which is broken without it. So the fix is only in 20. So my MPUnits project will never compile with Clang 19 because fixing a bug is less important than actually breaking ABI.
Thank you for reinforcing my point. So if I understand correctly, you're just the wrong crowd to ask this question. That would be...
Well, somebody has to disagree, and it looks like it's going to be myself. So, well, first, a slight explanation on how the committee makes decisions. So your vote would be completely useless. I'm sorry, because we never take decisions by majority. We take decisions by consensus, which is not 100%, but a high percentage of people agreeing. And when we do not agree on a change, status quo is preserved. And I think this is not a very aggressive way of working, but is something that has served very well the language the past at least 30 years. That is one thing. Now, if we go exactly to the point of ABI, I mean, not breaking the ABI never, that would be a bad thing. Breaking the ABI every 3 or 5 years is equally bad. I'm sorry, but I have been working with some companies, some of them in this room, where after some time, I was able to convince them to go to newer versions of the language. Had we been breaking ABI frequently, that would not fly. Besides that, in some companies, you are by corporate decision or sometimes by regulatory decisions, you are attached to a specific version of some operating system. And you cannot upgrade libraries when you want. So if we break ABI very frequently, that is just pushing them to never upgrade. And that is also a problem. I want people to be in the latest versions of the language so that in the next version, I can clean up a few things from the old version. So my dream is get rid of the preprocessor, for example, to give you an idea of what is my ideal language. This will take time, and retirement is coming, so I have a fixed deadline to achieve my dream.
Before going to the next question, I also want to comment on ABI. I hate ABI stability. And in the place I work on, we compile all our code on a regular basis, and it's not a problem. However, I'm aware, and actually we even do that as well, that companies do ship libraries for which the client does not have code, and they cannot recompile this library. They are bound to that ABI. This is not true for our library, but for some of these libraries, the company who's providing them may not exist. So there's no chance to compile it anymore. Or the compiler company may charge happily for an upgrade, which is also not viable in many cases. So I can understand where ABI requirements come from. I'm not happy with them.
Yes, thanks for outlining that. It's actually kind of clear why the committee is hesitant to break this. I think we agree that this is kind of balance, right? But probably we can't be in this state forever. Just the problems with existing ABI is just the pile up. I guess that at some point this just will break and a bit tsunami of changes. Maybe one change in the lifetime or for the foreseeable 30, 40 years, whatever. So the question is probably, how do you, with the current state of the arguments in the committee, how do you envision these questions to unfold?
Before that, just a reminder, the last time we broke the ABI was in C++11. Well, we did.
And just as a data point, I'm currently still managing that ABI break in a code base I inherited. Like, I inherited a code base that needs to upgrade its Linux distribution now because it has no support anymore. And that project depends on a commercial library that is only available in as binary. And that thing depends on the old ABI. Now, even though it was almost 15 years ago that we broke ABI, so.
I kind of have a question which is connected to this. Sorry, go ahead.
For managing ABI breakage, I could actually imagine that once we have a standard way to talk to the network, we could encapsulate these things, some of these libraries into services and go, yeah, that is built with something, and we go elsewhere with a different thing. So I can imagine eventually a way forward. Currently, we don't even have that ability in a standard way.
Yeah, so I have actually two questions. One is somewhat connected to this, and the second one is a consequence of it. So my first question is that does not this violate the rule that we don't pay for something what we don't use? Because many of us don't use this ABI, backward compatibility. So it would be kind of nice to just opt in if I use it, or I just don't if I compile the code every single time. So that's my first question. So how do you see this as a valid solution?
If we want to give you this kind of guarantee to stay in the old world and also optionally use a different new world, we are asking very lot from the implementers. And this is something we try to avoid.
Actually, that would have been my solution, is just to fork into an ABI incompatible C++ standard, to be honest, because I think probably 50% of the room would vote for it immediately. I personally 100%. And my second question is kind of based on this, and I think it would be really nice if you could just take turns answering it, because I'm really interested in the various aspects. So when you go to your manager in a greenfield project, what are your arguments that it should be done in C++?
I want to save the planet.
And word peace.
I will come back later. I just wanted to say that.
I can answer the greenfield project quite easily. I don't have that. I have only legacy projects, so it's not a question. And to some extent, as it may even be a hard argument nowadays to do things in C++ rather than in Python or JavaScript. But we have enough code to sustain
I wouldn't compare it to those languages, I think, but definitely I think it's right. So the new project button is not pushed very often, or I would say often enough that the C++ committee is pressured to give answers to that. On the other hand, I think what happens when you guys go retire, or even myself is kind of old now. So is there going to be a next generation continuing?
They are in the front row.
Good. And maybe we should switch sides and then I should ask the questions to them. Okay, so nevertheless, I would really be happy to hear your answers individually, because I think we have many different ones. And this is a question which I need to personally answer some situations that, like, if there is a new automotive platform being built, for example, should it be built on top of C++? Should it be built on top of Java? Should it be built on top of Rust? I don't know. So this is a question which comes up often. And if this question is answered in one way, that's kind of a commitment for 5 to 10 years. So I think it's important, if we look at how C++'s future is, what can we offer?
If I would like to answer it from my point of view, I work at a very small company and we can't afford training all of the members in our team on a new language. So we just stick with what we have and make the people as good as we possibly can. And this is the reason why we would use C++ in a greenfield project, just like we did in the past. But this is my point of view, and don't ask me as a member of the committee.
So my company actually uses almost all languages. So we have projects done historically in Java. We have active projects that started like this year in C#. I think there's some Rust stuff. We have new C++ greenfield projects. We have 20-plus-year-old code bases in C++. So we have web stuff I have no idea about. So the question whether to use C++ or not for us is mostly about, is this performance critical? Because if it's a desktop application without any critical stuff, why bother? Or just use C++ for the stuff in the application that turns out to be performance critical. That would be my answer. So I wouldn't say we must do everything in C++. It should be a decision taken based on the properties we want. Yeah.
So Bjarne Sturstrup has one of these quotes saying, if somebody comes to you and tells they have the perfect programming language, he is either a naive or a salesman. I would add, probably both. So there is, it's important to keep in mind that there is no perfect programming language. And I would say there will never be. And I agree with Mike about properties. So our classic selling point for C++ has been C++ is something that you should use when you need performance. Of course, this is still true. Well, you could say, well, I could use C. I would tell you, only if your program is less than probably 10,000 lines of code, or so. But if you are going to write an application that is 10, 20 million lines of code, good luck. Now, but these are part of the classic answers. One thing that I would add when I said I want to save the planet is energy consumption. That is going to be a key difference in the upcoming years. Currently, 10% of worldwide energy consumption is due to IT, and the prediction is that by 2030, it will be 20%. And you may have environment concerns or ethical, moral concerns, but energy consumption is also money. And this is something that you also need to keep in mind. I'm not saying that C++ is the only solution to that issue, but definitely is in the solution space to the energy consumption problem. So I think this is a thing. Of course, there are many cases where you are just driven by legacy because you have not a greenfield project. Also, you have to consider things like, do I have all the tools that I need available? Do I have all the libraries that I need available? In some businesses, do I have the certification tools and compliance tools that I need available? All these are things that need also to be considered.
I couldn't agree more. These are my arguments. The only counter argument, I think what I usually get is that, first of all, there are other people who want to take a kind of a slice of a pie, to say that. So all the languages are answering these questions or getting into a position when they are answering these questions, and they just tend to do much faster than we do. And I think they kind of overtaking us in some aspects in this regard. But that's not actually what I get from the management mostly, but it's like more like, and I think I would go back to do we have the talents? And that's actually my biggest issue, because the counter argument is that the C++ engineer, when I being asked this question, I always answer like, do we have enough C++ engineers or not? And then, yeah, we have a lot of C++ engineers, but it's still not enough because we have millions of people, but the quality of those people are not necessarily meeting the standards what's required to provide secure and proper resource usage, properly resource using applications. So it's just what is hard for me is that, can we be an alternative in terms of training enough good quality engineers? So for example, I can use the argument that yes, we have enough C++ engineers and they cost similarly as in other languages. Because what I see is that at the moment it's not the case. So we have a lot of engineers, but not many who are really good, or let's put that way, good enough to handle all the uncertainties of the language compared to what the requirements are in terms of security and resource management. And I think probably what you mentioned regarding the energy and performance, I think it's just resource management. It's just that C++ at the moment is really good in managing resources, which is definitely an advantage. But I think there are other contenders in this market which are coming quite fast, and they are answering questions faster than how we do, probably because of this consensus. And I agree that it has a lot of positivity that we have this for 50 years, right? We can still compile the same code, but does that make us kind of old in a way?
Let me give one more data point, and then I will leave Mateusz, that is waiting to say something. Now, one more thing that from the company perspective I would put into the equation, and you might agree or not, is because it is an standardized language, which means it is not owned by any company or by any organization that is not stable enough. We have seen in the past 20 years how a programming language was bought by a company. I can think at least of 2 or 3 different programming languages owned by a single company and what happened, or by a foundation, which for me is essentially the same. Some people is not happy with the ISO process. I think that the ISO process has a lot of advantages in terms of stability, in terms of protecting my investment, but because no single company can come and change everything. Sometimes you would like to change everything. I'm sorry, you cannot. At the end of the process, there are national bodies of different countries, and we take decisions by consensus. Sometimes I don't feel very well because the committee doesn't take the decision that I want. But at the end of the day, I have to recognize that this is a good process. So, you know what? If I do not consider C++ in the equation, the other programming languages that I have considered are those that are under ISO or ECMA or any other international standards body, which means that I think that C++ is much better than COBOL. I also think it's much better than Fortran. I'm sorry. I think it's better than Ada. It's only slightly better. What else do we have? Yeah, we have Prolog. We have Lisp. I mean, I'm not into. Sorry, we have C. Yeah. I'm not, and you can disagree what I am going to say now, but I am not interested in programming languages owned by a single company or by a foundation that has fuzzy rules that can be changed. And this is because from the, yeah, I was expecting something like that. That is because from the point of view of a company, you need to protect your investment. You are performing long-term investment, and you need to protect that. And you may agree, and I know that René is going to disagree. Can you wait until Mateusz answers? Yeah, okay. Right. This is starting to get funny.
All right, so I fully agree with whatever was said before, right? I totally agree with that. A few years ago, or assuming that Rust is not on the market, I would just say if you care about performance, but both runtime performance and, for example, also the, let's say, memory usage, right? Because C++ is much better memory usage than any other language in the world, assuming that Rust is not there. All you care about low latency, also, or basically handling your latency of your projects, or embedded, then you should, of course, choose C++, right? Another point is that C++ and energy consumption as well. Another point is C++ probably is the best language for generic programmers, I mean generic library implementers. They can provide the best abstractions for our users with the best syntax, with the best compile time safety, with no overhead. No other library, no other programming language can provide it. Even Rust doesn't have periodic templates, right? Doing any library feature without periodic templates, it's so hard, right? Talking about Rust, yes, it's trying to catch us, and it's a really great competition. Having a great competition actually is good for the market. We are still faster, and will be faster. But for example, ABI that you mentioned, and you mentioned many times, also keeps us, for example, to fix our performance issues in the compilers, right? So I would love actually to be able to break this ABI, fix, improve, and leap forward from the competition, again, in the performance chapter.
Yeah, well, I think one thing which is driving us, for example, not to go to Rust big time is, like for projects which are new created, is also getting people for that. This is as hard as C++, and there's less experience, so people are more conservative, staying right, we stay in C++. And then with respect to what a little bit what Daniel said, C++ is actually thriving on multiple compilers. This is quite unheard in other things, C being the other exception. And people are developing actively on things for C++, which other languages actually don't cover at all, like how do we interact with GPUs, for example, and integrating all of these things into one language so that you can actually compile that, program that stuff.
Maybe also add one more thing that may be controversial. Modern C++, actually, I believe, may be much safer than any other programming language in the world, right? Java, Python, all of them, C# have like garbage collection. This is just about memory. Some people say memory is cheap, you can always buy more memory, right? But let's leak one locked mutex, for example, and you are dead, right? In C++, it doesn't happen if you do this correctly with array pattern, right? Other languages just do not have those features, right? Doing C++ right, actually, it's safer, which may be controversial to US government, but it is true.
Hi, thank you. I'm going to ask a question about the standard in a minute, but I wanted to add something about the preprocessor. I do think it's pretty essential for a language to have a way to go above the syntax of the language to provide facilities for things like DSLs, or basically, if you can implement DSLs in C++ using templates and generics, that's pretty fun and it's pretty powerful. The problem is that the code is pretty much illegible. I mean, if you understand it and you wrote it, and it's been a short time since you wrote it, or you commented it extensively and documented it, then yes. But usually when you find 5,000 lines of code that uses templates, it takes you a week to get to understand. And I would argue that you could hide most complexity using the preprocessor, a decent preprocessor, because let me add that the preprocessor that we have is pretty limited. In my opinion, I think it has very few real use cases, and the ones it has can be, well, supplanted by constant expressions and evaluations and stuff like that. But yeah, I just wanted to add something like that, like the importance of a preprocessor, something that can handle the syntax from an abstract point of view. For instance, Rust has the, I can't remember what they're called. They're like macros, but they can receive the AST, the abstract syntax tree, from the function or the class or whatever it's modifying, and then operate on that. It could...
Reflection.
It's not reflection, because this happens before compilation. So you don't get a reflection in the sense you don't get a list of the fields, or you get the tokens. You get, this is a keyword, this is an assign operator, this is a parenthesis, this is a string literal. But I just wanted to add that. My question is about asynchronous I/O operations. I wanted to add if there's any kind of proposal or work in progress for implementing asynchronous I/O operations using rings. Like you've got the uring in Linux and you've got the IO ring in Windows, I think. I think it would be great if we could use those natively within the standard library. What do you think?
Yes, definitely. There's a proposal. I don't remember the name. If you look for my names, I've proposed it. We are not going to do that, probably. We will probably do something slightly more abstract based on tabs.
Based on what, sorry?
Tabs, i.e. TF tabs as kind of the networking infrastructure. The backing implementation can absolutely use IOU-ring or IOCP or EPOL, KQ, all of that.
So would it be something more like coroutines, where the standard provides the abstractions and then it would be up to the implementation, like the user to implement a proper runtime or usage of the native capabilities of the system?
Well, with C++26, we get actually an async interface. Like, how do we do async? And at the moment, or one contentious part of I/O was always, how do we interact async with the system? How does that look like? Now we get the interface, and hopefully in the next revision, we will get a binding to networking and possibly other I/O as well. So
okay, thank you.
This is definitely on the radar of quite a number of people.
I'm actually not going to disagree. I'm going to ask a meta question, which is there anything in the ISO process that you would change to address the variety of questions that have come up?
There is something that I would change, and I have filed a change request to my national body. For now, I failed, but I will work on that, which is that currently we have in the participation, you may have as many representatives from a single company as you want, but it's one person, one vote. I am strongly against that rule. I am also against the rule that allows that subcontractors of a company have independent votes. I think these rules in their current form might subvert some part of the decisions, but these are the rules of the game today, and I have to accept. I just try to modify. I am working on that.
Actually, I have a complaint.
Good.
We always mention performance. So we don't want to pay for what we don't use. Performance. So I remember, let's say, C++ 11, move was introduced, for example, or std function, and then people figured out that, okay, it's not really free. People sometimes get copy instead of move, or std function has memory allocations, or lambdas have memory allocations. But through the years, okay, like people were able to properly use it. And now I had some time to look into coroutines. Like what is in the standard, it's very difficult to use in practice. So effectively, you have to use libraries on top of it. For example, Boostasio. This by itself is also tricky, so you have to use libraries on top which give you more asynchronous primitives like boost cobalt. And then when you look at this, it's so when I hear, okay, like we pay for virtual calls, it's impossible to see where, like, whether performance is still good, what is actually happening under all these constructions. Like I'm not even talking about memory allocations, or I think it's impossible to understand. So if you like read the code sequentially, you can see that. When you use abstractions on top of abstractions, I mean, performance is, it's a very weak thing. It's, or weak thing. It's difficult to say whether the code is performant or not. So my question is, how do you see this going on forward? Because introducing such a low-level concepts and then making people use them through multiple levels of abstraction, the performance is kind of getting lost potentially, because you cannot trust whether compiler will optimize all these levels, whether there are some virtual calls, memory allocations. So it's and then if I work in an industry where performance is important, it's impossible for me to use this, because I don't have control over anything anymore. Thanks.
When you talk about performance, you're talking about performance in a particular use case. And this is what the problem is with many arguments about abstractions and performance and this kind of thing. you always have the option to make things more performant if you disregard all the other use cases. And this is why we have the abstractions. What we can do is make sure that our abstractions are as performant and that they have so few additional resources, if at all any resources required by these abstractions, to make sure that we can serve many, many different use cases. And this is something that we always need to take into account in our decisions, what we do. So if we want to make things as generic as possible, it's right. It takes experience to use the interfaces and put layers of abstraction on top of it. But this is a necessary thing that we have to do. Otherwise, we would just be inventing a new programming language like we did in the 50s and 60s to accommodate a particular use case. This is what I would say with the tension between being as generic as possible and make sure that we can make things happen such that performance and abstractions don't clash.
There is another part of the answer to your question having to do with the low-level stuff versus the high-level stuff, and you gave a perfect example with coroutines where we have very, very low-level stuff and you are missing the high-level components that would be more user-friendly. Now, there is another tension. If we do that, probably you have to wait 6 years more before we deliver the thing. So sometimes it makes sense to deliver the low-level part so that others can provide libraries or components that you can use. But if we block the low-level part just because we are still missing the high-level part, we are blocking everybody. So I'm not saying that this is a perfect answer. I'm just saying that we need to balance both forces.
Yeah, I think it's a big problem and actually an error to actually release a language feature and library features depending on this language feature in the same cycle. And because we don't have experience on the usage, because none of the compilers implemented this yet. And then you are happy because you have features, but sometimes we fail, and then everyone blames us that we have broken abstractions in the library that cannot be fixed because of API and the ABI, right? We are also users like you. If you don't have feature in the compiler to play with it, have like 2 or 3 years experience with this, it's hard. If you keep it like internally in the committee, having like internal compilers to play with it, there is only like maybe 20 people who will try it, maybe 30. Again, it's not enough people don't have an experience, right? Releasing this in 20 and then putting this to everyone. Right now you have plenty of experience how to use coroutines. We know exactly how to plan tasks, how to plan generator, because we had plenty of implementations out there. You can review them, compare them, find out what works the best, and then standardize, rather than trying to provide everything at once in one release, right? And also it takes time, like others said, right? We have limited resources. Sometimes we cannot fit in one cycle with everything.
Yeah. And then also briefly to address, all right, we have all these things which we can use, then not necessarily the most efficient approach to do some things. Like function is good for what it's used for. You pay a certain cost. If that's too expensive, don't use it. Like all right, we don't create cost for things you don't use. That's part of that. Some of the higher level components may be more costly, but they do not affect the lower level stuff, which you can still use if that is what is needed.
Yeah, maybe one more comment about coroutines specifically. Actually, I love the fact that all of the coroutines are language defined, not just library implementation detail. So basically right now you have, as I said, plenty of libraries providing tasks, but all of those tasks are compatible with each other. They can work in one library in one project together, interact with each other, right? It's not like having strings from every other vendor or vector from another vendor that are incompatible with each other. There's one hugely compatible feature, maybe providing blocks and pieces from different vendors. And this is so awesome.
Yeah, I want to add something to the energy consumption that Jose Daniel put on the table. That's a third concern for at least for me, that people feel the need to use more and more devices. So that also implies more energy consumption. That's to complete your exposure. But I have a question or a self-reflection. All of us, we want to have engage more software developers to use our programming language. So we know why the developers are hesitant to use C++. What the reasons that are behind that, and also we know what are the bare minimum features or that they wanted to have to use the language.
It was a question.
Yeah, not if we know first why those people are hesitant to use the C++, and what's the bare minimum features that they wanted to have in the language to be used by themselves.
Well, sometimes I feel that a lot of people is discouraged by features that they should never use, but that they see because they were used 25 years ago, and content is replicated and replicated over the internet, and that makes the language to look more difficult than it is. I'm not saying that C++ is an easy language. It's a hard language, mostly because we use it to make very difficult things. So if you are doing, I don't know, high-frequency trading, or you are making a plane to fly, those are difficult things. So there is a complexity that is just inherent to your domain. And then, of course, there are a number of features that I would say that I would not allow most people to use. So we say today, don't use reinterpret cast, please, for example. And that is just one example. I think one thing where we need to improve is in education, providing good training materials, and in a way that is amenable to new developers, because, I mean, C++ is hard, but it's not so hard. So inside the committee, we have a study group where we are trying to work in defining learning paths and just outlining a way of teaching C++, and this is what we can do. We cannot go to the internet and erase all the things I would like to erase.
Hey, I've got, the first one is a question regarding energy consumption. Should we measure the energy consumption of half-an-hour compile times? And
depends how much time you compile and in how many devices you execute the binary.
And the second one, well, you just answered it, but I have raised my hand. So anyways, in what ways, which you partially answered just now, does the standard feels like the pedagogical problem that C++ has with its size and everything? In what ways is the C++ standard approaching it? What does this group in particular do? What subset of C++ it explores, or I don't know if you can answer any of those.
I just want to come back to your first question about the compile times as well. Come to my talk tomorrow. I will refer to this a bit, because people blame templates for compile times. Typically, it's not the root case.
And about education, what we are doing is not defining how people should teach in detail, because everybody teaches in a different way, but at least defining what are the topics and what is the order and so on. So we are defining a meta guide so that a training can use that to try to teach in the way we think it should be taught. Besides that, of course, there are many individual efforts. I can say that in a few weeks we will be here at this university starting to deliver a number of free online courses, and the first edition will be in Spanish, and then there will be a second edition in English. And this is what we can do from this institution to try to help the community.
When it comes to teaching and learning the language, I would add to that, I have the impression that much of the books that you can find on the internet is not really up to speed. For example, if you have books that are around for 20 or even more years, and these books are just layering new stuff on top of the old stuff, and in the beginning of the book you first learn the old stuff before you approach the new stuff that you really should learn, then we have failed in teaching the language. And this is why I would recommend try out new books, try out new material that doesn't teach you the stuff that you should no longer use anymore.
Also, I highly recommend basically going to trainings and workshops on the conferences as well, like we did before this. We have Klaus here, right? I am here as well. There are other trainers doing trainings on conferences, and of course in-house if needed as well, right? This is a great source of knowledge. Often, sometimes, sorry that I would tell you, but often, sometimes even bigger than actually the conferences. Some people come only for workshops because they cannot afford both, and they decide to go for workshops because they claim they learn more on the workshops than during the week conference, for example.
Hello. We know that we are very good programmers, everyone, but sometimes the application crashes, and then my question is, there is any idea of standardization of where the application crashes, where we have different compilers, we have different operating systems, so a way to have information that is compatible everywhere, and so you can understand what happened in your application?
Well, I can think of only that at least now you can get at any point in your source code the stack trace. And I mean, it's not that much, but it's something that not everybody is aware of.
Accidents happen. We know in production, the application crashes, and you never know where it happened.
You can write in your log file, and you can write the stack trace.
That's what we say, that the standardization could be maybe a good idea, because we all have logs, we all have ways of doing, no? So.
Hi. There were already some questions about complexity of C++ standards, and it's common words that C++ standard is not a reading for average developer. I'd like to know your estimations for how complexity of C++ standards grows over the time. Is it time in square or faster? And in comparison to, as you mentioned before, complexity of C++ is related to complexity of domains. So is complexity of C++ growing faster than complexity of the worlds around us? And the second question about this. So there were a few waves of increasing demand for computations over the world. So there was high frequency trading, and it's still on the plane. We still have cryptocurrencies, and now we have this generative AI. So do you use large language models for analyzing C++ standards for your committee's work? Thank you.
All right, so maybe I will ask for show of hands because it's quite late, so maybe let's wake up a bit. Who would like to have enum to string function in the library that just works with enum? Hands up. Enum to string. Enum to string. General function. Enum to string in library for everyone. One function. All right, who would like to have serialization for any type? Who would like to have loggers or command line parsers, right? Everyone would love to have those features. In order to have those features, we have to increase the complexity of the language to be able to implement that. We had reflection, right? Reflection is probably not every one of you will have to learn reflection, but thanks to reflection, we'll be able to implement those for you, so you have really easy to use abstractions, ready to use, right? In order to have possibility to have vectors and strings in context functions, we had to add more complexity to the language. In order to have format validation, STD format, to verify your formatter at compile time, we had to add more complexity to the language. But you as end users don't have to know about those features, and probably should not play with such feature as well. But you will use them every single day, and then we'll say that C++ is so friendly to use or safe to use, depending on the library feature you use.
Let me add one extra question. How many of you have defined more than one instance of a variadic template? Oh, that's more than expected. How many of you have, at some point, spawned an STD thread? I'm surprised by the answers. Thank you.
Hi. I would like to know your personal take on the safety thing. For a little bit of context, I understand that some safe C++ proposal was summarily dismissed basically because that was like a sort of port of Rust's parallel checker to C++ or something.
It was not dismissed, it was just not brought to the end.
Well, maybe, okay, so maybe
it was presented and discussed thoroughly. It just didn't succeed, as many other proposals.
Yeah, all right, but just to complete the kind of context that I wanted to give before you state your opinions, then I understand that the committee is like betting on these safety profiles from the outside as a totally uninformed individual. I see on one hand that these profiles are a little sketchy right now, but on the other hand, maybe over-promising or too hopeful about what a static analyzer can do without further annotation, because at some point in time, if you want to have or be as powerful as the Rust's parallel checker, we will have to do some kind of lifetime annotation. So it's a little fuzzy, everything, and I would like to know your personal opinions on what's the approach of C++ with respect to safety.
Maybe I can answer it. I have answered a little bit about it in my talk this morning. I think we have different ways to improve on that. A safe C++, this particular proposal is a possible way to do it. I wouldn't even say that it's dismissed. It was too close to the end of the C++ 26 cycle to discuss it as thoroughly as it should be done. It will probably be back on the plate in C++ 29 cycle. But I think annotations, in particular lifetime annotations, are not exactly user-friendly. I don't want to see lifetime annotations in the language if we can avoid it. If it's unavoidable, then let's do it. But on the other hand, there are possible other ways to go, and we should explore what is the best approach and what fits into C++ the best. And this is something that needs to be discussed. And actually, right now, as far as I know, there's the first round of discussions about what we are doing in regards to all of these questions, reducing the amount of possible safety issues. Lifetime annotations are in regards to safety issues. And let's see how quick we can get along this path. And I wouldn't rule out anything at this point.
So, without going over that paper in particular, one thing you have to think about is the complexity involved. Like we are talking about, C++ is a complex language. And roughly estimate of the 2,000 pages, 700 are the language. The rest is the library. And the paper essentially needs us to double that, roughly speaking, because we have this new world where everything is safe. And as it turns out, our library isn't. So we'd need a second vector, a second string, and so on and so on. All the STL, so all algorithms wouldn't work in that world. Maybe ranges, though I wouldn't be surprised if it turned out ranges were impossible with that world either. So actually doing this would take us decades. I think decades is the right measure here. So if we figure out, like Daniela said, that we have to do it, you will see us doing this step by step, because that's the only way to do this. We couldn't deliver this in, say, 36 if we started now. That's impossible.
No, I totally understand. And I agree with you that the proposal was a radical one in that respect, but my concern is that thinking that the gradual approach to that will lead us somewhere else that this initially proposed, in terms of, okay, we will have to have a different or a new standard library, because otherwise, because the current model is inherently unsafe. So it is up to us to discover whether this is the approach to go well.
So I'm not a core wording expert. I'm mainly doing library work in the standard committee. But what I've heard by some core wording experts is, like, we need to figure out how to actually specify the lifetime guarantees of Rust, like the borrow checker, which is currently, from what I've been told in Rust, an implementation. And we'd have to figure out how to actually put it into wording that we could put into a standard without mandating a particular implementation.
I was checking the new embed feature that I think is going to be added in C++ 26, and I was pretty surprised that it actually is a preprocessor directive. So you write like #embed something. And I was going to ask, like, why that instead of, for example, a const-eval function, now that we have const-eval?
Sometimes you need also to consider that even if we are not 100% compatible with C, we try to be reasonably compatible with C, and C added #embed.
Then can we please have like memset, the secure version of memset that doesn't clear the memory, please, that C has?
So in terms of having a const-eval function instead of #embed, you expect a const-eval function to always yield the same output, right? That's a question.
Yeah, wouldn't it be the case?
If I concurrently modify the file system. So, but in the same thing happens with the preprocessor, but that's not an argument to extend that horrible madness that comes from there.
Well, but in a single invocation, you would get the same result.
In one
invocation of the compiler?
No, because between you embedding it the first time, I could still change it.
Yeah, well, that you could mandate implementation to cache the file somehow. Wouldn't the same thing apply for the preprocessor too?
The preprocessor is a horrible mess. And you may have noticed that for the last 20 years, the committee tried to get further and further away from it. And I think in Bjarne's Design and Evolution, he talks about how templates were designed as a way to get rid of some of the madness of macros. I'm not convinced that we will get rid of it ever completely, but yeah.
That was another question I had. Like, what do you do like for platform dependent code? Like, for example, if you have a SIO local socket that is not defined under Windows, what do we do with that? Like, how do you do that with the macros?
Well, yeah.
You don't.
Well, I mean, I will show you maybe if we have time tomorrow of a funny use case for the preprocessor that tells you we have missing language features.
Fine, thanks.
And conditional implementation, conditional compilation doesn't mean you have a good solution to the problem that you were describing. Having lots of different versions of your program in the same translation unit doesn't mean this is good. Maybe you should put the solution that is better and more portable into a different way. Don't overuse the preprocessor and don't use too much conditional compilation if you can afford it. The only good way, a good thing about the preprocessor is maybe X macros, but this is the only thing that I would actually accept as a preprocessor kind of thing.
Just very briefly on something you said, right? Why don't we get that memset thingy? I think we actually get it. There's a paper which is currently going through process to update the C reference to C++, to C23 instead of. So I think that is in.
I am old enough to have done the equivalent of templates with macros. And that is sort of vaccine to try to avoid the preprocessor as much as I can.
Yeah, and I would like to refer to your question about branches and portability of the code. Code that has plenty of preprocessor branches is not a portable code. It's a code that was ported a lot.
Yeah, I think this will be the last question because we are approaching to exceed half an hour the original schedule.
My question is, aside from like more secure C++, how do you guys think the language should evolve? Like, what's important in your view? So my question is, the security is like the hot topic these days, right? So aside from that, what do you think is the most important evolution in C++ standard?
Profiles.
You mean as in future or stuff you will get soonish?
No, future. Like not C++ 26, let's say beyond 26.
So I think your question was outside security, right? Yeah. Yes. So my take is networking. That's very simple, and that's what I'm pursuing.
I think most of the things I am interested in are on the way. Things like reflection, I think this will change a lot. And after that, we will have bright new ideas of things to do. Really. This is a game changer. Okay, I think we are going to close now. So thank you very much, everybody.